center of the workbench. It shall be ensured that the photometer is at the same height as the rotation center of the workbench and aligned with the photometric center of the test 8 luminaire. Okay, secondly, 8 luminaire warm-up. A photometer is used to continuously monitor the output of the mirrored 8 luminaire, which can be determined as stable when the following conditions are met. If it's in a continuous light state, the photometric value is measured every 5 minutes, and the relative variation of 3 consecutive measurements is less than 0.5%. And if it's in a rhythmic light state, a fast photometer is used to measure the effective intensity every 5 minutes, and the relative variation of 3 consecutive measurements is less than 0.5%. Okay, thirdly, measurement distance. And here we recommend that the initial distance between the photometer and the 8 luminaire should not be less than 20 times of the largest dimension of the test 8 luminaire. And then enlarge the distance, and so that the distance increases by 1 meter each time, and measure the luminous intensity at each distance. When the relative variation of 3 readings is less than 0.5%, it's considered to meet the photometric distance law developed by Lambert. Okay, the third part, measurement method. The first section, measurement of luminous intensity versus angle. Okay, firstly, for pencil beam, carry out rotating scanning in the horizontal direction and vertical direction respectively at an angle interval of no more than 0.1 degree from the reference axis. The scanning range shall not be less than 2 times of the corresponding nominal beam divergence angle. And then the photometer collects and extracts the photometric signal at each angle and measures the illuminance value. Then calculates the luminous intensity at each angle. And finally, draw the horizontal and vertical luminous intensity profile versus angle respectively. Okay, the secondly is fan beam. The measurement procedure is similar with that of the pencil beam, except that the angle interval in the horizontal plane should be no more than 1 degree. Okay, the second section is measurement of luminous intensity versus time. Okay, firstly, measurement direction. For pencil beam, the direction should be that of the reference axis, and for fan beam, the direction of any 10th percentile intensity measured in the section measured of luminous intensity versus angle on the reference plane should be taken as the measurement direction. In general, the measurement direction is denoted as 0, direction. Okay, secondly, measurement of luminous intensity of continuous light. A conventional photometer is used to measure the luminous intensity in the direction 0, and the average value of 3 groups of readings is taken at the luminous intensity of this continuous light. And if the test AtoN light is modulated, ensure that the deviation of 3 readings are within 1%. Otherwise, a fast photometer should be used. And the fast photometer is used to measure the luminous intensity versus time for 1 second in the direction 0, to calculate the modulation period. And the average luminous intensity within 1 or more complete periods is taken as the luminous intensity of this continuous light. Okay, thirdly, measurement of effective intensity of rhythmic light. And there are 3 methods. And the first one is direct measurement method, which is almost the most accurate one. The AtoN light is set to the rhythmic light state. When the stability condition is met, a fast photometer is used to measure the instantaneous intensity versus time of each flash individually. The measurement duration shall not be less than 1 period, and the sampling frequency shall not be less than 500 Hz. Then the effective intensity of this rhythmic light can be calculated according to MEM. Okay, the second method is conversion measurement method. In this method, that a fast photometer is used to measure the fixed illuminance at any position, and then set the AtoN luminance to the rhythmic light state and warm up it. After the completion of its warm-up, then a fast photometer is used to measure the instantaneous illuminance versus time profile of each flash individually, and calculate the effective illuminance according to MEM. And then the effective intensity of this rhythmic light is calculated according to this equation. Okay, the third method is the estimation measurement method. In some occasions with low requirement, that the effective intensity of rhythmic light can be estimated by referring to the method of IALA Guideline 1135 Annex B, and based on the light waveform and the rhythmic character information of the test AtoN luminance. Okay, here is the list of content that can be added to R203. And in the second part, measurement requirement. Okay, the first section, general requirements. There are 2 items: laboratory environmental conditions, power supply requirement. And the second section, measurement equipment. There are 3 items: technical requirements of gonal photometer, and that of the spectral radiometer, and the spectral correction factor calculated by strict alternative method. And for the third section, measurement preparation, and there are 3 items: installation of AtoN light, criteria for judging the completion of AtoN light warm-up, and determination of measurement distance. And for the third part, measurement method, okay, the first section, there are 2 items: measurement of luminous intensity versus angle of pencil beam and fan beam. And for the second section, there are 4 items, and which are measurement of luminous intensity of continuous light, 3 measurement methods of effective intensity of rhythmic light. Okay, action requested of the committee. At present, IALA's recommendation on marine signal light measurement is R203, which is planned to be developed into a guideline in the next task plan. So the details in this input paper are closely related to R203. We hope the committee will consider China's work on the measurement of luminous intensity of AtoN light, and if appropriate, the relevant content of this input paper can be included in the new guideline developed from R203. Okay, thank you all for listening. Comments are welcome.
Thank you very much. That's a very interesting presentation there, and it sets the benchmark for luminous intensity to remove any, to give a conclusive outcome, and it takes away uncertainty in the way the measurement is done. But it is also clearly a complex topic, and you need to be good at mathematics to follow this. And I'm sure Working Group 1 will be pleased to take this into the guideline from R2003, and I can imagine good debate with Frank and Alwyn and Malcolm on this topic. So thank you very much. We're right on time. Any questions on this one? I don't see anything in the chat. So Alwyn, one question from Alwyn, please.
Yeah, I just wanted to sort of agree with you, Simon. I thought it was a really good presentation, and there's lots to discuss there, and I fundamentally agree with everything that you've said. Just a quick question on the moving the photometer away at 1 meter intervals in order to find the far field value of the intensity. Have you checked the equation in the existing R203 about the minimum photometric distance, which is on section 9.8? Have you see if that correlates to the distance that you're finding in moving the photometer away?
Okay, thank you, Alan. You mean that the photometric distance that's introduced in R203. So you mean that if I have checked this theory in this recommendation?
Yes. Yeah.
Yes. The proposal that's introduced the Euro way we used in our laboratory or other manufacturers, equipment manufacturers laboratories method that's we when we measured AtoN light, that's we use this way to find this measurement distance. And as for the formula or the methods you introduced in this recommendation, that I haven't checked it before.
Okay, thank you, Lingyan there. And if I may say, Alwyn started his question by saying he fundamentally agrees with everything you say. This is lovely.
Sorry.
Sorry,
Come back.
It's lovely to see the families. It's lovely. Alwyn started saying he fundamentally agrees with you. This is a rare compliment, Lingyan. Alwyn never says that to me. So you take that as a compliment, and thank you. Okay, so thank you very much for your time, and I can see good discussion following that. So thank you.
Okay, thank you, Simon. Thank you, everyone.
Okay, so now we move over onto the next topic of oceanographic and tsunami monitoring buoys, and I'm delighted to welcome Samir Benouda from Mobilis to talk through the technologies on this exciting topic, which will lead us into the guideline that IALA in ENG Working Group 2 with Peter and Jörg are devising for complementary use of AtoN, and I'm sure that this will be of interest. So Samir, I see you on the list. Are you able to take the screen, please?
Thank you.
Long time since I've shaken your hand, and I look forward to that next time.
Good morning, everybody. Thank you, Simon, for the introduction. I am very happy today to be here with all of you for this presentation, but I am also more happy to leave Dr. Maureen Garzen to give this presentation and to introduce the technology and how to conduct a project of oceanographic buoys with all the complexity and all the parameters to integrate before any project. So thank you, Maureen, to give this presentation.
Okay, thank you.
Good morning. So can you see my screen?
Yes, we can, but it is not on. We can see your computer, but the slide is not. We can see all the graphics around the slide as well.
Oh,
it's not full screen.
Yeah, if you go to full screen or slideshow.
I don't know how to.
Oui, tu as affichage plein écran.
Okay.
Mode
Lecture. Okay. Just a minute, please.
That's okay. No rush.
Oh, what happened? So I will try again. Sorry.
Okay, that's okay.
It is not that. I don't know why there is a problem.
That's okay.
Yes, Samir, can you share it? No? I don't know why it doesn't work.
Ouvre la présentation PowerPoint. Dans ce cas-là.
Yes, I know, but there is a problem. Is it okay this time?
Yeah, well, we can see.
Yes?
No, we're already seeing the We cannot see the presentation full screen.
Oh, I don't.
We can see the presentation in thumbnail on the side.
Samir, do you have the presentation? Oh, it's okay.
Ah, this is
Yeah.
bad. This is good. Okay.
Yes.
Off you go. Over to you. Thank you.
Sorry. That's first, I want to thank you to give me the opportunity to share with you this presentation. It was not easy, sorry. And I will make my best to present Mobilis know-how and what we can do for Oceanographic and Tsunami monitoring buoys in order to upload new IALA regulation and discuss it, of course. So Mobilis has a range of standard data buoys platforms, but what is Mobilis' strength is its capacity to customize data buoys. All our data buoys can be unique according to the requested sensor, energy wanted, etc. It will not be the same if we need only solar panels or if we had to add, for example, wind turbines or fuel cell. And the challenge is really to propose a data buoy having a good stability and sufficient buoyancy reserve to propose a really safe system according to IALA regulation, of course. And the best illustration of Mobilis adaptation is actually the data buoy called DB24100, the huge buoy never seen for the moment, 5 meters diameters and 24,000 liters buoyancy. But what is happening and when we need such a buoy? What we can remark is that year after year, the need for data collection increases until today, and this buoy, the greatest modular buoy ever designed or built, based on navigational modular buoys conception. It was a real challenge to offer such a performing buoy. And behind such a large-scale project, we can see a difficult future is already looming, because this buoy, the huge one, enormous one, is already too small. And this remark leads us to ask ourselves just one question: how and why such buoys comes into the world? What are needs that justify this production? And how can we discuss to have a safe system? So as we said, Mobilis has a range of standard data buoys, but we can adapt to the needs for data collection. And what happened for this, the development of these data buoys was totally based on this need. And what was the need for this greatest buoy? That was the important number of sensors. But why was it necessary to produce the greatest buoy never seen? The solution is that many sensors to collect data imply many consequences. In one hand, a bigger buoy which can support all sensors, and on the other hand, new ways of energy, because many sensors means greater energy consumption. And it was what I said, maybe solar panels will not be sufficient, and we need other ways of energy. And that's what Mobilis has to comply with the request regarding this data collection. And it is how Mobilis can develop its solution and advance data buoy research. And what happens is that there is a solution to propose for data collection, but there is a floating object, the buoy, to study too. That's why the mooring design is very important, and Mobilis is able to calculate the adapted mooring line and the best solution for the mooring leg of the buoy. And the most important point is that it will be a safe solution, of course. So we can say there is 2 points. The buoy floating system, the buoy, with the adapted mooring line calculated by our naval engineer. And then we have to provide data collection. Many sensors will be able to give all the data, available data, high quality data, and that will be the performance of the system, the floating buoy system and data collection system. So you can see all the sensors on the buoy. Then there is an interface for the data, and we can keep this data on the computer and, of course, study this data. Sorry. So, 2 points on the buoy. The buoy should be a stable platform to guarantee security of sensors, men, and data records. So it is the aspect of the floating buoy system. And on the other end, a safe way to guarantee a good measurement and preserve the integrity of the sensor and of the sensors. Because what we want is to have the data, of course, and we have to study the buoy performance. And so you can see all the elements we have to take in account to validate the buoy. So, for example, buoyancy reserve, visibility, and of course, compliance with IALA regulation, the really important point on which we have to discuss. And so here is an example of what happened for the DB, greatest DB. It is the element for the power supply communication, and as I said on the previous slide, is for the example, you don't have just a solar generator. You need wind turbines, fuel cell, and all the elements have to be safe to provide the best system. Here are the dimensions of the DB24. So you can see how huge it is. You can see the solar panels, the sensors inside, and all the elements inside. So really, why it is so big? It is because, of course, we need space to put the sensors. And if we have more and more sensors, we'll need a buoy more and more big. So as you can see, 5 meters diameter, 5 meters high, big one. And what is important too, another important point is the modularity of this buoy. The buoy is more stable and can be more easily adapted. Moreover, it is easier for the maintenance, an important point for buoy validation, and an important point according to the IALA regulation, of course. So finally, the DB24 projects show us data collection is more and more important, and this data buoy offers a solution, but it is already not enough. And what is actually the greatest buoy is maybe the smallest of the next generation of buoy. And that's why we have to work together to be able to propose the best solution for data collection and to provide a safe system and be able to upload a new IALA regulation in which all will be okay, all will be safe, and we can work again and again for more important projects. So thanks for your attention, and all your interrogation are good. And with Mr. Samir Benouda, we will try to make our best answers. Thanks.
Maureen, thank you very much for that, for your time and the very interesting presentation. 5 meters diameter, 24,000 liters. That's a huge buoy, and you can climb inside it and work. Just a question from me. What sensors would you fit on this for tsunami monitoring? What sort of sensing would you be looking for?
What sensors we can put on the buoy? Yes.
Yes.
Yes, it is. It depends really of the project. So you can have turbidity sensors, pressure sensors, all the sensors to study ocean and to collect data and see how it is developing and what are consequences, for example, of human activities on the sea.
So you can have a pressure sensor at the mooring, and can you have a height sensor on the buoy?
Yes, well? you can. Yes, you can have sensors on the buoy, in the mast, as we say with the view, and sometimes we can have sensors more on the float or yes, of course.
Okay.
It really depends on the project.
Yeah. Okay. Fine. Thank you. Any questions from anybody on this tsunami data gathering buoy? I know Working Group 2 have this as a topic. Any questions coming through? Nothing in the chat. Okay. Right. And I know you have worked with Peter Schneider on the buoys. So yeah, I think this will be very interesting, and I think the topic, and we look forward to your input into the guideline we're developing. So Maureen, thank you very much, and for your time and your presentation. Thank you.
Thanks.
Okay, so now we're moving, we're looking now back to China for Tianjin port, and we have Li Ang, who is an engineer with the Tianjin Ace Navigation Department at China MSA, and has a particular interest in the maintenance of Ace Navigation. So here we have AtoN distribution adjustment practice in the main channel of Tianjin port in China. So Li Ang, are you there?
Hello, Simon. Can you hear me?
Hello, Liang. Yes, you are very quiet, but I can just hear you. Ah, there we go. I can see you now.
Okay. Thanks for this opportunity to let me make this presentation.
Liang, you're very quiet. I'll just check my speaker. Okay. Just a little bit. Maybe if you could speak up would help. Or is it just me?
It's better?
Better, yes, better. Yes, yeah. Thank you.
I should be loud.
Okay.
Okay, let's see. I'll share my screen. Can you see this presentation?
Yes, we can.
Okay, so I'll begin. Morning, everyone. This is Liang from China Maritime Safety Administration. I'll present you this proposal about AtoN distribution adjustment practice of the main channel in Tianjin Port, China. This proposal mainly introduces the AtoN distribution adjustment practice of the main channel in Tianjin Port, China, including 4 parts, which are the background, navigation facilities, distribution adjustment, and benefit analysis. This proposal provides useful references for the application of the AIS navigation. Background. Tianjin Port, China is close to the Bohai Sea with geographical coordinates of 38 degrees 59 minutes 8.8 seconds north and 117 degrees 42 minutes 5 seconds east. It is the largest comprehensive main harbor port and one of the major ports of transshipment for energy and raw material in northern China. Part of the main channel of Tianjin Port is compound channel. The navigation environment is complex. There is drift ices in winter, the average annual fog day of 14.6 days and maximum of 26 days. The city background light at night is a big confusion for sailors. There are many equipments. Oh, sorry. Many equipments or technologies have been mature application for many years and jointly used in Tianjin port to ensure the safety of ship navigation and marine environment protection, such as AIS, Beidou satellites, four-season universal light buoy, solar power, etc. 2. Navigation facilities. 2.1 ATON facilities distribution. Before the adjustment, Tianjin Port Compound Channel distributed 87 ATON facilities, including 1 lighthouse, 2 lamp piles, 71 buoys, including 31 four-season universal light buoys, 8 long-term ice buoys, 24 traditional steel lamp buoys, 4 multi-function light buoys, 4 hinge-type lamp piles, 4 radar transponders, 7 real AIS beacons, 1 virtual AIS beacons. You can see here is the facilities distribution of main channel of Tianjin Port.
Sorry, really, yes, we can only see your first slide of your presentation.
Yeah. Yes, your PPT now is working.
What's now?
Now
better?
Now it's, yeah. Yes.
Okay, I'll do this way.
Okay.
2.2 AIS base station. Tianjin Port's main channel contains 2 AIS base stations respectively built in East Dike and South Port. Each configures 2 sub-R40 full-function AIS base stations, which realize AIS signal comprehensive coverage and provide both real-time and historical AIS data. Those stations played an important role in improving maritime supervision efficiency and assisting maritime investigation. 2.3 Communication via public network. At the end of 2017, the Dagu Lighthouse 3G/4G telecom communication base station was carried out for opening test and acceptance inspection. The construction and opening of Dagu Lighthouse telecom base station has opened up the data communication link of the main channel east of Dagu Lighthouse and the surrounding anchorages, enhanced the coverage of the communication signal in the waters of Tianjin Port, and solved the public communication problem. Meanwhile, according to the construction agreement of the Lighthouse Space Station, a dedicated bandwidth is reserved for the transmission of video monitoring and visibility equipment data on the lighthouse to better serve the sea-related users in Tianjin Port waters. 2.4 Beidou Course Station. In 2016, China had built 10 Beidou course benchmark stations and 1 area data processing center in Tianjin Port area. FYI, course means continuously operating reference station, which can realize the real-time centimeter level positioning service. They played an important role in dock lifting, channel dredging, offshore surveying and mapping, ship berthing, submarine pipeline laying, and offshore drilling platform construction, and other offshore fine operation. Part 3, Distribution Adjustment. 3.1 Unified buoy system. After the adjustment, the deep water channel of the main channel in Tianjin Port uniformed 42 four-season universal light buoys. The shallow water channel uniformed 16 conventional steel light buoys. Navigation service in winter is exactly the same as other periods. It provides an unified system, stable and reliable navigation service throughout the year. You can see here is the four-season universal light buoy, and here is the conventional steel light buoy. 3.2 Green facilities. The four-season universal light buoy adopts solar power supply system, as we can see here, the solar panel, and green polymer polyethylene body, which suppresses the marine biological pollution, eliminates the rust removal and pollution cleaning operation with the steel buoy, extends the replacement and maintenance cycle, reduce carbon dioxide emission and paint use, and helps the construction of a green port in Tianjin. 3.3 Digital facilities. Using AIS and Beidou technology to carry out the digital modification of navigation facilities in Tianjin Port, we have set 35 real AIS AtoNs interval in pairs in the main channel. Users can use the existing general ship navigation instrument with no further investment, realize the digital perception of traditional visual AtoN, which provide a visual plus digital navigation services, significantly improve the navigation efficiency and safety in fog, night, or bad weather in Tianjin Port. This picture is the real AIS AtoN shoes in the ECDIS. This is the information display of real AIS AtoN, and here is the radar display of the real AIS AtoN. 3.4 Real-time perception. Using GPS positioning, Beidou short message communication, and AIS short message communication to realize real-time sensing and remote control of the working status of AtoN, which improve the efficiency of repairing and navigation, enhanced the ship safety as well. Sorry, this 3.5 multifunctional anti-ice lamp. The anti-ice lamp integrates many modules to meet the ice resistance and stability level to apply in frozen ports in winter, such as automatic light source control, GPS and Beidou positioning, Beidou communication, AIS short message communication, and lamp status monitor. The internal state monitoring module also can monitor the internal humidity, temperature, and acceleration of the lamp. During the operation process, especially the ice period, we can analyze the influence of the drifting ice through this monitoring module to provide data support for making inspection and maintenance plan. This one is for the four-season universal light buoy, and this one is for the conventional light buoy. Part 4, Benefit Analysis. 4.1, Acquisition, Replacement, and Maintenance Cost. 42 four-season universal light buoy in deep water channel can save 705.6 thousand in acquisition, 60.2 thousand in replacement, and 352.3 thousand in maintenance. And the 16 conventional steel buoys in shallow water channel can save 152,000 in acquisition, 209.6 thousand in replacement, and 100.7 thousand in maintenance, respectively. 2. Inspection cost. The ordinary annual inspection cost is 492,000. We need to inspect the buoy monthly. After the adjustment, we just need to do a seasonal inspection using the integrated real AIS AtoNs, and the annual inspection fee is 164,000. 4.3, improve the effectiveness of AtoNs. The adjustment provides a unified system, stable and reliable navigation service throughout the year. Therefore, the number of overwater construction is also reduced, which effectively improving the navigation environment and ensuring the efficiency of port production and bring incalculable economic benefits to port logistic economy. We hope this also can bring the committee's attention to China's work in AtoN distribution adjustment practice of the main channel in Tianjin port, hoping to provide cases for the adjustment in other ports. Thank you all for listening, and thank you again for giving me this presentation opportunity. That's all.
Yeah, thank you very much for your.
Okay, I'll stop my sharing. Okay.
Thank you. Can you hear me, Liang? Is my voice coming out? Okay.
Yes.
Thank you. Thank you for your presentation. Very interesting to see the mix of AtoN that you have put into Tianjin port, and I see Tianjin port is the main port for Beijing. So it is obviously a very big organization there. And I think the other item that interested me was the ice lantern, how strong that looks, and I think that will be of interest to other IALA members. So thank you for your time. Do we have any questions for Liang on the AtoN mix in the Tianjin port? Any questions come through? I'm sure this will come through. Okay, there was a question there. Any questions come through for Liang on Tianjin port?
I see, Simon, sorry, I see a question from Tit Parji from Estonian Transportation.
Okay, can we have that?
Yes, I would like to know what's the life expectancy of those plastic buoys. What do you have calculated or expect?
I'm sorry, could you repeat it?
How many years you think those plastic buoys will be usable? What is the life expectancy of those buoys?
We start to use the four-seater universal light buoy since 2015, and this adjustment, I believe, is about 2020 or 2021. I'll check it after this mess. And my memory is about we did this adjustment. We over this adjustment in 2021, and this is the conclusion of the adjustment practice.
I think the gentleman from Estonia was asking how many years do you think the plastic buoy will last? 10 years? But, you know, you have had 7 years.
The producer of this plastic buoy have guaranteed us this plastic buoy can use at least 15 years.
50?
Yeah, we can use at least 15 years without fade or any broken situation, except for the
okay.
Yes, about 15 years.
Thank you.
Yeah.
Okay. Right. Well, thank you very much for your time, Liang, and very interesting to see that mix in Tianjin port. Thank you.
Okay. Thank you, guys.
So, and I'm sure that will be discussed in working group 2. Peter Schneider, we have your hand up.
Yes, I had a question. Did you have, or do you have experience with the ice behavior in reality? Are there ice fields which have hit the buoys, and what happened? Is there experience?
Yes, we not only we did the experiment, we just use it in the ice period in Tianjin port, and I remember I made the presentation about this four-seater universal light buoy last year at the ENG15. Yeah. And if you are interested in this, I can send the my last presentation to you by email or other.
Yeah.
Okay.
Okay. Yeah.
I'll email you after this.
Okay. Thanks.
Okay. Thank you.
now we move on to, we're looking now, changing from into RaCons, and we have a presentation from Liu Chunhai from China MSA, and looking at the introduction of tests to gain information on the next generation of RaCon. So, Liu Chunhai, if you are there, please.
Yes, good morning, Simon.
Good morning.
Good morning, everyone.
Ah, yes, we can see you. Good.
Yeah. Okay, can you see the presentation?
No, we don't have your screen yet.
Oh, yeah. Just a moment. Just a moment. Yeah, it's
Have you done the share screen?
yeah. Is it okay now?
No, no, we cannot see. We can see you, but I can't. Oh, something happening. Oh, here we go. Yes, yes. Now we have your
Yes.
screen. So
I will share my screen, and Chunhai, you can just ask me to proceed to the following slide, please.
Can you see the screen?
I think we see Heine's screen. Is that right, Heine? Ah, yes. Now we see your
Okay.
screen. We see,
Ah,
see
okay.
skiers. Someone skiing up a mountain.
So it's okay now.
Is it okay now? Yes. Over to you.
Oh,
Thank you.
Okay. Good morning, everyone. Good morning, Simon. During this presentation, we would like to have some introduction to the next information, to the test information on next generation RaCon. Actually, we have been involved in the research and the development of next generation for more than 3 years. This document introduces the experiments on the next generation carried out by the China Maritime Safety Administration in the waters of Lingyan River near the coastal area of Fuzhou in 2021, and puts forward some ideas and suggestions related to the next generation RaCon. This presentation contains mainly 4 parts. The first is purpose. Second, background. Third, test information. Fourth, conclusions. The purpose of this document is to share information on the testing of next generation in China, to request the ALA ENG committee to pay attention to the relevant information and to explore the possibility of updating the guidelines of next generation RaCon so as to promote RaCon to adapt to the development trend of radar. The related documents mainly is R101. So first part, background. First, problems that may arise from the development of solid-state radars. In the 20th century, new solid-state radars were developed due to military needs. By the end of 20th century, solid-state radar technology was introduced to navigation radars. Compared with traditional magnetron radar, solid-state radar has the advantages of strong anti-interference, anti-rain and fog ability, high resolution, maintenance-free, and lower radiation, etc. The right photo is the solid-state radar installed in Guangzhou in China It is for VTS system.
Louis, you're not moving your screen. Maybe we
Yeah.
can see the purpose of the document screen at the moment.
Yeah. Because of the much smaller peak power of the new solid-state radar signal and the new pulse processing method adopted, the current RaCon cannot be tricked by new solid-state radars. With the increase in the number of ships using solid-state radars, RaCon's failure to respond to solid-state radars may bring hidden dangers to the current safety of ship navigation. Second, considering that IALA ENG15 session, draft G1147, IALA workshop of ERPS, all of the above reports repeatedly make mention of solid-state radars and the possibility of RaCon being updated to be able to respond to solid-state radars. Third, ITU. In 2018, ITU already proposed the need to update recommendation ITU RM 8244. This is about the technical parameters of radar beacons to provide for compatibility with radars using solid transmitter technology. Fourth, IMO. IMO has regulation about RaCon. It was published on November 19, 1987. That is IMO Resolution A615. Actually, in the Annex 2 of the resolution, it says, radar beacons designed to operate on a wavelength of 3 centimeters, this is X-band radar, should be capable of being interrogated by any navigational radar equipment operating on any frequency between 9,320 MHz and 9,500 MHz, and respond within this frequency band. So, tests. China Maritime Safety Administration has carried out research and experiments on the compatibility of new generation RaCon with solid-state radars. Test equipment radar. At present, solid-state radars on the market are mainly divided into 2 types: FM continuous wave small radars and pulse compression radars in terms of transmitting signals. The testing radars selected are 2 common solid-state radars on Chinese market: 4G FM CW radar and Hello 3 marine pulse compression solid-state radar. Both of them are produced in Europe. Solid-state radar, 4G FM CW radar. The power of this radar is very low, with a peak signal power of only 165 milliwatt. The peak power of conventional magnetron radar is generally 4 kW to 25 kW. Hello 3 pulse compression radar. Hello 3 adopts the signal's processing method of pulse compression, and the peak power of the signal is around 25 watt. Normally, for pulse compression radar, the peak power of signal is about 100 to 200 watt. So this Hello 3 radar is also has very lower peak power. Shipborne radar. The Shipborne radar is a frontal magnetron radar, which was originally installed on ship. It is about 7.5 meters high above the water surface. This is made in Japan. Test vessel. Test vessel is buoy tender. You can see these 2 white objects. they are the antenna of the solid state radars. The right one, the round one is 4G's antenna, and on the left is close range antenna. RaCon was placed on the bank of Lingyan River, about 3 meters high above the water surface. So test location at the time. The test was launched on the Lingyan River in Fuzhou, near the coastal area, on March 2nd to 3rd, 2021. The weather was cloudy. Due to the geographic limitation, the maximum distance tested was about 10 kilometers. The RaCon was placed on the riverbank at the starting point of Maui. This is the starting point, and the ship sailed along the Lingyan River to the upper right. This is the final destination, and the distance is about 10.3 kilometers. Test results. Magnetron radar. The onboard magnetron radar had very good results. The farthest test distance was 10.09 kilometers due to the bend in the river. This is the display of the signal. In order to avoid the signal coverage, the display distance was artificially extended by 12 kilometers. So if we had not artificially extended the display distance, it should be appeared here, merged in the background signals. So after extended by 12 kilometers, the signal appeared here and it's more clear. This is pulse compression radar. Pulse compression radar had also achieved very good results. The actual distance showed in the photo is 9.84 kilometers. Also, in order to avoid signal coverage, the display distance is artificially extended by 12 kilometers. So the signal appears here. Originally, it should be appeared this place. So after extended by 12 kilometers, it appeared here, and we can see clearly. So FM CW radar. FM continuous wave radar also got a good display. Just because the signal strength of FM continuous wave radar itself is very lower, its working range is also short. Therefore, the maximum distance of the RaCon we tested was about 5 kilometers. Also, in order to avoid the signal coverage, we extended artificially by 12 kilometers. So test conclusions. From the test results, the new generation of RaCon can not only respond to the traditional magnetron radar, but also to the new solid-state radars. In view of the above-mentioned successful experiments, it is technically mature and feasible to upgrade the RaCon to adapt to the development of new solid-state radars. The relevant good practice could be used to update the IALA R101 recommendations, etc. Now, we also say some words about busy harbors and the ERPS. Traditionally, RaCon performed poorly in busy harbors, but thanks to new technology, next generation RaCon can improve service to radars in busy harbors greatly. Second, if adopting the similar technology, next generation RaCon can work as eRaCon to have ERPS function. So this is the reference. 615 is from IMO, and this is from IALA, and this from ITU. There are some other documents related. So, committee action. The ENG committee is invited to pay attention to the experimental information and to explore the possibility of updating the recommendations about RaCon that can adapt to the new solid-state radars. I expect there are some questions and we would like to reply detail by email. So if anyone would like to ask any question, you can also email us. This is our email. Thanks for listening.
Thank you very much for your presentation and for taking the time to share this with us. RaCons is a very interesting topic, and especially with ERPS and the workshop we held, and the start of the new development for those, and of course the whether solid-state radars pick up new RaCons. Very interesting to see what you have studied there. So thank you. I'm sure Working Group 3 in ENG will be interested in the paper you have submitted. Any questions here on the testing for the next generation of RaCons? Any questions coming from people here? I know the radar positioning system workshop we had would be interested in this because that is very much the next generation of RaCon coming in to fit in within the next generation of radar. So thank you.
Thank you.
No questions coming in. So Liu Chunhai, thank you very much for your time. Very nice to hear from you. Thank you.
Thank you. Okay,
now we move on to R-mode update from Michael Hoppe and Stefan Gewies. So Michel has a diploma in radio engineering some 30 years ago and has been working with the German Federal Waterways Administration for many years in the field of radio navigation and PNT systems. And Michel is Vice Chairman of Working Group 3. And we very much look forward to hearing the update on R-mode. So Michel and Stefan, over to you, please. And I see you have the screen. Thank you.
Yes, thank you, Simon, and good morning, good day, and maybe also good evening to everybody. So, yeah, we would like to give a status update about the recent developments around R-mode, and it's a shared presentation, and my colleague Stefan from DLR, he will give some explanations about input papers recently provided as an input to ENG15. So a short overview, I will give a very brief introduction into R-mode and will also give a brief update about the recent developments, especially within the R-mode Baltic projects. And as said, Stefan will then contain some information about an updated standardization roadmap for R-mode and some new messages with respect to RTCM. For those who haven't heard about R-mode is standing for ranging mode, and it's a planned maritime terrestrial radio navigation system as a backup for GNSS. And the way it is working, it's that it is providing timely, synchronized, precise ranging signals by using existing maritime radio infrastructure. And as such, we have identified mainly one with the maritime radio beacons sending GNSS corrections within the medium wave frequency band, and also VHF transmissions using AIS locations, but the idea is really to use VDS R-mode on it. And you see here history about work on R-mode is going back to a couple of years with various projects and studies and test beds made in various areas around the world. Why using R-mode? So when we are looking at the situation on board a ship, SOLAS vessels, for example, so the primary source is just using single GNSS services. And We are all knowing that GNSS is suffering from disturbances, interference, man-made or other interference coming from sun, solar activity, and so on. And it's also lacking on-site integrity information. So the circumstances at the receiver itself stay unknown in most of the time. And also we know about threats like jamming occurring meanwhile on a daily basis, especially when it comes close to the coast or in harbor areas. And also spoofing attacks are still rare, but have been reported rising throughout the world, and also in some areas of the world, like also the Eastern Baltic Sea, for example. When we are looking to IMO, there's also a need for a resilient PNT, and the compelling need here is based on a gap analysis made a couple of years ago, and they are demanding resilient PNT and also the use of uncorrelated information, integrity and ranging information to provide a backup or an alternative system to GNSS. And also coming with immunity against GNSS jamming and spoofing. And also when we are looking what is already there, we could see that there's a performance standards for multi-system radio navigation receivers and also associated PNT data processing guidelines. And they are more or less already suitable for Armored to jump in or any other backup system. And data processing guidelines are also providing mechanisms how to use and provide the best result for position navigation and time and integrity to the user. So the following slide gives an overview about calculations. What is the achievable performance? And here you see the area of the Baltic Sea with the red dots representing AIS locations, and triangles are existing radio beacon. And if we turn them to armored, you see what would be achievable in that area. So this range giving daytime and also nighttime accuracies shows that there's a possibility to provide accuracies in the range of 10 to 30 or 50 meters, which is, to my opinion, still good enough against having nothing if GNSS fails to some reasons. So what to do to make it happen is just when we're looking to the armored on the MF domain, so is some modification of the existing DGNSS radio beacon by adding a precise clock or also a new modulator, and also maybe some monitor facilities to look a little bit better to dynamic effects. So in the Armored Baltic project, we could achieve to install and set into operation 8 MF armored sites. And so they are sending already armored signals in the south and southwestern area of the Baltic, and enable us also to do first measurements, static and also dynamic measurements on a ship. And we have also prepared testbed for VDS Armored using 4 installations in Poland and in Germany. And this is also part of the larger MF testbed, so we could also use them to do and perform combined test. And this is planned for the next month, and I hope I can report about the VDS Armored tests and combined tests at a later stage. What we also did is to implement monitors, armored monitors, far-field monitors, to monitor the performance over longer time periods, also to learn a little bit more about the error effects in that new technology, and also to install on-site monitors to analyze and also compensate dynamic effects within the transmitter chain. First installations are already made in Sweden and Germany in that respect. So finally, first results gained through one of the measurement campaigns, which was east of the island Rügen. And you see here we drove House of the Nikolaus, so to say, and to see what is the performance in dynamic. And we could see that the performance was about 22 meters when we compensate also for some ground conductivity errors. And I think this is very, very good and results. And but there's still room for further improvement by using better phase correction maps and also maybe a DR mode in the future. And also we developed a lot of various prototypes and hardware solutions as well as for the MF domain and also for the VDSR mode. And that continues the first half of the presentation, and I would like then to hand over to Stefan, and I will click on the slides on your, yeah, thanks.
Yeah, thank you, Michael, and good day to everyone. Michael already explained that I will address the two inputs paper related to an R mode roadmap and also to R mode navigation messages we think we will use for medium frequency R mode. Let's start with the roadmap. And before we can have a look at the roadmap, I will shortly introduce the organizations which are involved in the R mode standardization. And these are 5 important organizations. The first one is the IALA. Here we are working especially on the implementation matters using this different frequency, medium frequency and VHF frequency. But we have also here to specify the R mode methods. And here already a first guideline is available for VDSR mode. The second organization, which is important, is RTCM. And here we have to define especially the navigation messages. I will report later about it. We have to think about differential R mode. That was already mentioned by Michael beforehand. And RTCM is also in charge when we are working on test standard for the receiver equipment. Here we can think about the multi-system receiver, but there's also already a new special committee which address especially VDSR mode. This is a special committee 138. The third organization which is involved is the ITU and especially ITUR. And here we have to speak about the topic spectrum related, the spectrum, and also any implementation matters related to our 2 signals of opportunity. The fourth one is the IMO, already mentioned by Michael beforehand, that they are really interested to have an alternative to GNSS. And we already approached IMO with, or we start with it to write some information papers to make them aware that there is something ongoing in the development. And IMO might be also involved in case we need here some performance standards and also some performance requirements. And the last one is here to mention the IEC, which is responsible for the test standards and for the type approval of the receivers, and maybe also for the transmitter side. And IEC is also working on interface definitions, and this is also important because we want to integrate our R mode equipment into existing installations. Could you please go to the next slide? Okay. And the question is now, how could this be done when we are looking into the timeline? And I will present you now on this this slide and the following our idea of a roadmap for the R mode standardization. It's more or less based on already existing roadmap, which was drafted during the R mode workshop of the IALA. But now, due to some delays caused by the corona pandemic, it was necessary to make an update and also to go more into the details. And so the last point I want to mention here, this roadmap is right now mostly developed from the perspective of the medium frequency R mode, because in the engineering committee we are working especially on the medium frequency R mode. And so far we have to discuss this guideline also with the ENAF committee, which more or less addressing the Vds R mode activities. Okay, but let's have a look at the roadmap. And here I want to start more or less with activities we see for the IEC. IEC is very important because at the end we want to have a receiver which works. And here we have to develop a test standard. And it might be a good time to start these activities within 2023 because we are already on a good way to define the service here with IALA guidelines, so that we have the hope that we can finish our IALA guidelines at the end of 2023, that we can start with the standardization of a multi-system receiver, which includes R mode in 2024 to 2025. There's something that I forget to mention. Our approach is to use the existing, the IMO MSR performance standard to develop a receiver standard that includes, beside the terrestrial navigation component, which is R mode in our case, also GNSS. Somebody is not muted. Could you please mute yourself? Okay, thanks. Okay, then for the standardization on the IALA, please back one. Okay, there I already mentioned we working on the guideline for the MF and VHF frequency, but we plan, especially at this meeting, some liaison notes related to our roadmap and to R mode messages to the RTCM and RTCM and to the ENAF committee. Okay, now please, next slide. Okay, and then we will go over to the three other organizations, RTCM. Here there are, especially for the standardization of interest, two special committees. This is 104 and 138. The first one is developing the RTCM2 standard, which we think it's important for the provision of R mode information to the user. Here we will provide an input, as I already mentioned, to RTCM, and we hope that in the next years this can be used to update the RTCM2 standard. And the second special committee, 138, already mentioned it, is working on Vds R mode. For the IMO, so we it took a while that we prepared here an information paper to inform to make them officially aware that there's there is a development of a terrestrial navigation system, and we developed an information paper for MSC 105. This is developed from Germany and supported from Finland and Poland. And this will give an overview about the medium frequency R mode and also the Vds R mode, so that we more or less can then, based on that, later work with the IMO with respect to standardization There's also another paper right now in development in the ENAF committee. Here we were also reviewing it during this ENG committee meeting, and this will also send to IMO this year. The next steps for IMO are so far not clear. Here we have to discuss further what is necessary. The last point I want to mention here is ITU. There should be an update of the Vds standard this year, which also contains a link to the VDSR mode. And very important milestone for ITU are the World Radio Conference 23 and also 27. And we have also to work on the radio beacon standard for the transmission of the signals, because we have here for the medium frequency R mode also include these additional carriers we introduce. And here we put a marker to the year 2024. Well, I hope this could work. And what's very important, I want to stress it here again, we have to work together with ENAF on this roadmap to put also all the necessary information from VDSR mode into this roadmap, and also to harmonize our activities. Next slide, please. Okay, now let's jump over to the second input paper, which is related to the RTCM navigation message for the medium frequency R mode. And I would like to start with a collection of information we need for the R mode system. It was shown in the figure at the beginning how it looks like, and in principle it's not so different to the GNSS. And so far we would need similar or same information. But I put it here on the slide and grouped it a little bit. So let's start with the transmitter health status, synchronization status, and signal status. So these are some basic information which should be provided regularly to the user, that he is aware what is the status of this R mode system. Can I use it for ranging and positioning, or is it not possible? These information should be made available once per 10 seconds, so that we can meet the requirement to alarm the user within 10 seconds about the usability of the system. Furthermore, we have information related to the signal characteristic. When was the signal transmitted? Where was the signal transmitted? And also some basic information about any clock errors of the transmitter clock. These information should usually be provided once per minute, so that an R mode receiver is capable to perform positioning at least 1 minute after a cold start. The last piece of information is important when we want to combine the MFR mode or an R mode receiver together with any other system like GNSS or in principle also VDSR mode. Here we have to be ready at least within 5 minutes. I mentioned here a second R mode system. It could be that different R mode systems have a different time scale. Then, and the last information which could be transmitted is about any planned maintenance. So when it's planned that the transmitter will be switched off, we should inform the user beforehand that he is aware that the system will be not available. Next slide, please. Okay, and how could we do that? The best way would be when we are using the already existing data channel, which is from the radio beacon channel, which provides DGNSS correction with the using this RTCM2 message format. And the most important thing what we have to consider is we do not want to interrupt the current service. So we have to find a way to bring this information into this data channel, but do not disturb the current installed receiver, DGNSS receiver on board of the ships. Let me give you some basic information. The data rate is here typically 100 to 200 bits per second. So you can see this also in the EALA beacon list on the EALA website. Some details to the message structure. We have for each message contains several words. Each has a length of 30 bits. Usually we have always two header words, and they are following up to 31 data words. And now on this next slide, we will see how we can make use of it for the medium frequency R mode. So we designed the message 55. This contains, beside these two header words from RTCM, with another third header word. I have named it here R mode header. And this R mode header contains all the information which are not possible to put into the RTCM header because we cannot really change it. So here we have all the status information, monitoring status, signal status, and also some time information. And the last important information is a submessage ID. Because we cannot put everything into the header word, we have to define some additional submessages which contains the static and dynamic navigation data. Submessage 0 is foreseen to the transmission of only the most important information, only the status information. Could you please go to the next slide? Okay, how does it look for the data? Here we defined 4 submessages. The first one contains the R mode system time week and some signal delays of the different signal components of the R mode signal and also clock offset. Then we have submessage 2, which contains static information data, what is the position of the transmitter antenna, and also what is the some special characteristics of the signal itself. Then we have the submessage 3, which contains all the information which is necessary to relate the R mode system time to the universal time coordinated. And the last one, in case that we lost the connection to the central time distribution source, then we have a free running clock and we should inform the user about it. And here we have the ability to provide some general information about this free running clock. When we are looking at the timing of these, or at the time that is needed to provide this information to the user, then we will need 3 to 8 data words. That means 90 to 230 bits. And when we are using a data rate of 100 bits, we would interrupt the DGNSS data stream for 0.9 to 2.4 seconds. And that was important to keep this interruption time short. Yeah, next slide, please. The last one, summary. Okay, I hope that we could together show you that we make here good progress. We are working on a very important topic. It was addressed by the IMO. And currently available in the Baltic Sea, we have a testbed which contains of 8 medium frequency R mode sites. 4 of Vds R mode sites are prepared. We have some ongoing measurement activities within this testbed. We have here some very good results already. And at the end, we have here of our project, we have some prototypes available for the shore side, but also for the board side. And it's now important to make the next step to go on with the standardization. For that, we proposed we worked on 2 input papers. The first one that shows the R mode standardization at IEC, IALA, IMO, RTCM, and ITU. That it's, for our opinion, possible to do. And the last one is that we propose some navigation messages which could be used for an amendment of the RTCM 2.3 standard, which is used today for the transmission of the DGNSS correction, and we also can use it for the integration into the RTCM 2.4 standard. Thank you for your attention.
Thank you very much, and Michelle, thank you very much for that. And we'll see if we have any questions come in. But just before they start, just out of interest, excuse me, how much support are you receiving, or how much interest are you receiving from outside bodies like IMO, ITU, IEC? Are they interested, or because they are getting a lot of new technology requests for support, do they see this as, oh no, not another one, or do they say, oh, this is interesting? How do you find that?
Yeah, maybe when I try to give an answer on that, it's difficult to say. Let's say, I think there's an interest because when you're looking around the world, so having a backup to GNSS, I think meanwhile there's a large interest in having alternative PNT solutions. But there's already a lot of various developments around. I mean, there's still discussions on ELORAN, and I think it depends a little bit on the region of the world, and so we have ARMOD, which is split into the MF ARMOD and the VDS ARMOD. So depending a little bit also on the situation, on the local situation, the geometry, the geographic issues. And we have the enhanced radar positioning system, which is maybe a short range solution. And I think the idea, and what we also try to sketch here, is that the multi-system radio navigation receiver is really the step forward. So resilient PNT is a mixture of various solutions, and the performance standard on the multi-system radio navigation receiver could combine the various solutions, and that's, to my opinion, something which we need to address, and because currently we still have that single GPS L1 receivers. Most on the equipment on board the ship is still that old-fashioned GPS L1 receivers, which are really, let's say, not the best performance. There's a possibility of jamming and spoofing. So I think we need to foster our initiative towards IMO and also IEC, that we have alternatives, what they're looking for, but we need to implement them and need to go to address the existing performance standards to get developed on the IEC and the other domains. I think that's the message, and I hope we can help from IALA with this kind of roadmap. Also, the developments on the enhanced radar positioning system could include it in this initiative, and I think that is the way to go. Sorry for the long answer.
You have paved out the way you have developed this, and ERPS will probably follow a similar format on a related resilient PNT. I see we have a question from Mahdi Al-Masawi from Minas in Bahrain. Mahdi, over to you.
Yeah, good day. Thank you, Simon. Thank you, Mike and Stephen, for the interesting presentation. I just have two questions. I wonder, my voice is clear? Can you hear me properly?
Yes.
Yeah. My question is that according to your presentation, Mike, that the best accuracy achieved was around 22 meters. Is there a plan to, prove it to be like more accurate is this system considered to be a replacement for the differential global positioning system? I mean, what is the aim of that? Or it is like a replacement for a LoRaN C or eLoRaN? So as Stephen said, that it would be like better than having nothing. For example, if there was a jamming or spoofing, or the GPS service was not there. And my last question is, what is the, if that could be answered, I mean, what is the minimum number of stations required and the distance between each terrestrial station? Thank you very much.
Stefan, would you jump in?
Yeah. So for the question related to the number of stations, so this is in principle not so easy to answer, because we have the idea of R mode is to use already existing infrastructure, and the infrastructure for the distribution of the differential correction, and also for the for AAS or for the Vds base station is not optimized so far for ranging mode. And so far we have in certain areas not the best geometry for ranging and positioning. So it's at the end we have to optimize the geometry to perform let's say accurate positioning. And here we have to look into each region. It's for the Baltic Sea, it's the geometry is, let's say, fantastic, because we have here the size. So when we are going over the water, there's a distance of maybe 300 kilometers, and this is perfect for medium frequency R mode. But if you have all these stations aligned along the shore, then it might be more difficult. And you may think about to add additional transmitter. So the best way would be here to have an so-called coverage prediction, as it was shown by Michael at the beginning. So this could be done in principle for each region, and then you have more or less an idea what can be expected. Then you had another question related to the accuracy. In principle, this question is also once again related to the number of transmitter sites you have and the geometry, because it's something like a multiplication factor. But right now in this measurement, we could achieve 22 meters. And we see here there's still some room for improvement, because what was addressed by Michael, these differential approach, this is for sure something that could help to remove effects which appears over the daily basis. And we have for medium frequency R mode especially the challenge that we have to know what is the ground conductivity on the path from the signal from the transmitter to the user. If it goes over sea, it's very simple. If we go more to the inland, or if there are some islands, then it's a little bit more challenging. But we are working on that, and we have already ideas to improve the performance. But we can, this is some ongoing research activities, but improvement should be possible.
Yeah, for the accuracy, like a similar water area that you have, you did the test bed on, I mean, on offshore, so you have a good grounding and all of that. So do you think that the accuracy in a short term, like by the end of this roadmap, you will get a much better accuracy? You are aiming to get a better accuracy? You are focusing on that, or you just want, you are making this another service available for PNT for the mariners.
So the goal is to improve the accuracy, but there are some limitations. This is due to the fact that the wavelengths we are working here is for medium frequency R mode. It's 1 kilometer, so that we will not reach a decimeter accuracy. That's not possible. But we can, I think 10 meters to be maybe a little bit better than 10 meters. This is achievable. So we will never have a replacement for GNSS. Then we have to, that's much more expensive. But we can here to have something in case when GNSS is not available, so that we at least can finish something in maneuver which was already begun. We can use also R mode to prove if a GNSS solution can be trusted, because if this is far away caused by spoofing, then this might be identified.
Thank you very much. Thanks a lot.
Mm-hmm.
Thank you.
Simon, you're muted.
Okay. How is that? Can you hear me now?
Yeah, but the microphone is malfunctioning. There's something wrong with yours.
Okay, yeah. So
yeah, no, it's good. It's good now.
Okay, fine. Yeah, I have when it goes quiet, I put my external speaker on, but it upsets the mic. So thank you, Michelle and Stefan, for your interesting update on R mode and for your good insightful questions there, Marty. Thank you. So moving on now to the next topic, we have Guillermo Fernandez from ESSP, and looking at SBAS standardization update. Guillermo has an MSc in telecommunications engineer from Madrid, and joined GMV in 2011 working on GNSS business. And in last year, he joined ESSP as the receiver standardization expert. So here we have it, as we say, straight from the horse's mouth. Guillermo, we look forward to your update. If you can take the screen, please.
Sure. Okay, so can you see my screen?
Yes, we can, thank you. We have the full screen, the EGNOS, and the blue screen. Thank you.
Okay, perfect. So, well, first of all, good morning or afternoon to everyone. So I'm going to perform just a short presentation of the current status of the development of the IEC standard for SBAS L1 maritime receivers. So, as some of you will already know, this standard is under developing within two different standard groups. So first, from one side, we have the Iec Tc80, and specifically we have a working group called the PT61108-7, where a first draft of this standard has been already reviewed, and some comments were provided and some discussions were held last month. And then we have, from the other side, the Sense and Elec JTC5 working group 8. And within this European working group, also the standard was reviewed prior to be presented to IEC. And of course, new versions of the draft under develop is going to be reviewed by both standard group. So the objective of all this work is to have the new standard published for mid-2023. So, well, this is the, as I said, this is the project team 61108-7 which was created within the Tc80, IEC Tc80, with the objective of developing this new standard. So currently we are 25 international members within the group. And well, you can access look for additional information of this group within the IEC webpage. So the standard under development, which is the 61108-7, is focusing on the SBAS L1 augmenting GPS L1 signals in order to comply with the harbor entrance and approaches and coastal waters operational requirements. So this standard is composed by a scope section, minimum performance to be complied by the receiver, method of testings and required test results to pass these tests to certify the receivers. And then there are two additional sections. The first one is just a high-level SBAS technical characteristics, and the second one is the high-level description of the procedure for provide the SBAS PVT solution. So it shall be clarified that currently DFMC SBAS and other GNSS augmented by SBAS are out of the scope of this first version of the standard, and they will be considered when appropriate in the future. So just to give some background of the current status of the draft. So in June 2021, the new work item proposal was approved at IEC level. And then within the European Commission project called MARES, the first draft was published, was provided to IEC at November 2021. And then within the MARES project, in December 2021, all the tests included in the draft were executed and the solutions were provided. So on January 2022, comments from the IEC working group and also outcomes from the MARES projects were gathered in order to discuss all these open points in the meeting held previous month on February at IEC. So this slide shows the different stages where the standard must go through to be published at IEC. So right now we are in the working draft step. And as I already said, we already had the first meeting of the working group on February 2022. So right now we are updating the working draft with all the outcomes from that meeting. And the objective is to have 3 different meetings within this project team at IEC. The idea is to provide 3 different working drafts for each meeting. And the objective is to have on September of this year the committee draft. So then from that, the voting process will start. And the objective is to have to publish the IEC 61108-7 for mid-2023. So basically, to sum up what has been presented in here is that this new standard will ensure a safe use of SBAS by all Shipborne receivers at worldwide. And just to include the major milestones achieved and to be achieved are that on June last year, the new work item was approved at IEC. And on November 2021, the first working draft was presented. As I said, now we are working on the second version of the working draft and with the objective of have the publication of the standard for the mid next year, 2023. So of course, as always, EALA members are welcome to participate in either Iec Tc80 or the Sense and ELEC Working Group 8 to review the standard, the draft, and provide comments, of course. Just for any additional information that you would like to know, just please contact me or any of my colleagues from ESSP and we will glad answer any comment. We cannot widely provide the draft under development, but of course, if you would like to have additional information about this or even maybe provide some comments and review it, please do not hesitate to contact me, and I will do what I can do to provide to you somehow a copy of this or or we will see how we can manage it. So this was all to be presented just in this presentation. You can see this was a very short presentation, but please, if you have any comment, question, or whatever, just please do not hesitate to ask it.
Guillermo, thank you for that concise and brief update on SBAS standardization. And it's good to see this happening. And as time moves on, we can see more of a clear deadline for, you say, mid next year now, so about a year away, and we can then enjoy the EGNOS standard for SBAS augmentation. So thank you. Any questions for Guillermo on this topic? I know you're involved in Working Group 3 and discussions there, and we look forward to that. Okay, I'm not seeing any questions. So Guillermo, thank you very much for your time in putting this together and taking time to speak to us. Thank you.
Okay, thank you.
So now we move on to a related topic, maybe. We're now talking about development of shipborne receivers for Galileo. And we hear from Marcos López Cabeceira, and I hope I pronounced that correctly.
Yeah.
And
yeah.
Marcos has a master's degree in physics and electronics engineering, and has quite some years' experience now in the maritime section of GMV, managing projects and business activities with maritime stakeholders, and it specializes in GNSS user segment division as a maritime consultant in that field. So Marcos, over to you, please, if you could take the screen.
Yeah, thank you, Simon. I go.
Okay, we can see you, and we can see the screen. It's not in presentation mode, but we can see your slide.
Yeah, maybe I could move it. It's
That's
okay
good.
now?
Excellent. Yes, spot on. Thank you.
Okay, good. Okay, so thank you, Simon. So I go then. Yeah, this was an input paper submitted for the ENG15, as you already know, to present this project. Okay, this project that is already running from 1 year ago, but as we will see and explain you the context. So first, I have included some slides, but first of all, it was just a context for this project. Yeah, the context is that, as we already know, there are several different constellations of GNSS satellites, like Beidou, GPS, and others. For example, Galileo from the European perspective. This is sure that using those constellations somehow together in a standardization way, but somehow together increases the robustness and availability of the solution for the PNT photo receivers. We know that at the Galileo point of view, there is an authentication service that is already in the space now, the signal in the space, as at space. That's true, but it is in the space and in the testing working group. So this is part of the context of the project, and it's important to know that this authentication service provides protection against spoofing attacks. On the other hand, we all know, and in fact, it was commented in the armored presentation by Michael and Stefan, the concept of IMO resolutions for 1 and the amendment 1 related with the multi-system seaborne radio navigation services. This is also an important input for this project, that this MSR IMO resolution is indicating to use at least 2 independent GNSS sources. So finally, I could comment that this project was or is funded by USPI, by the European Space Program of Europe, and with the objective of developing multi-constellations and double frequency receiver, but we will see in some more detail next. I go. Next. Yeah. Just very quick. Here we have just a very quick show of the consortium that we could show GMV as project coordinators with our big experience with GNSS standardization aspects in very different topics as integrity and the design and development, and also providing receivers, DNSS receivers. On the other hand, we have SAP as one of the most important manufacturers of high performance shipborne navigation receivers, as you already know. And we have identified two important laboratories as VSH from German and JRC laboratory from the European Commission that are going to be the ones to perform the tests of EX certification tests, identify, and those related with the spoofing. So the ASGARD objectives are divided in three sides, we could say. Yeah, the first one is to develop a double frequency Shipborne using E1 and E5A. This is taking advantage of GPS and Galileo working in those frequencies in the same band, so we could take advantage of it in terms of the hardware of the receiver using two frequencies for four signals, two from GPS and two from Galileo. On the other side, the objective is focusing the IMO resolution 233. This is related all with Galileo and also with that performance standard for MSR, as we have commented previously. This is for 401. So finally, we have included into the project to perform the Iec not only for Galileo or only for GPS, if not for both. So we are going to perform the Iec for both test standards, following both, as this has been somehow described by the MSC 401 from the performance standard of IMO to go for both. So this was included like this. It's true that in the European regulation, but this is only European, I mean in red color for MED 456, those standards EEC for GPS and Galileo are not included together at this moment, okay, currently, but maybe in the future this will be working like this as commented by IMO. As last objective, the implementation of OSNMA. OSNMA, this is the authentication service of Galileo to implement it and to support the resilient PNT. Some activities and planning of the project, some typical ones of management and so on, but for me, just to focus on some more relevant things, we have a strong we have already performed a strong work on requirements, taking into account all those regulations from IMO and others inputs from IALA and Iec. And I could say that there is a verification and validation process, a strong process on this, where it will be include those tests and certification for those laboratories, and also including onboard field tests to test the final equipment performed. In terms of the timeline, just to share that we have performed, we are more or less in the middle of the project. We have performed already the requirements and the design is already closed. So we are currently in the implementation phase and soon with the verification and validation with laboratories. So at the end of the year, we will have some very interesting results from those outputs from the laboratories. And final slide, just to make a summary of added value expected from the project. This is to provide the maritime navigation equipment, this is true, but using a new multi-constellation MSR approach. This is including both EX for the receiver to ensure that the equipment is compliant with both at the same time. Yeah, and also including double frequency and commented to you and OSNMA authentication service. So in terms of standardization and regulation, in terms of that standardization that is already existing or already in place, we are going to be aligned with those with GPS and Galileo, with those performance standards from IMO and those from Iec. But in terms of those processes that are ongoing, for example, with the performance standard from IMO for MSR, ASGARD is a proposal for that double multi-constellation double frequency, focus on making robust, resilient PNT and better performance and integrity functionalities. And also this will be a base for the implementation of OSNMA. processing capabilities in the receiver, and also for the future standardization. So that's all, I think. Yeah.
Marcos, thank you very much. Very interesting and good to see some augmentation here, some resilience being built into the GNSS system using Galileo and GPS. So thank you. Yeah, very interesting. Any questions for Marcos on this topic? I'm sure Working Group 3 will be interested in that. I see Guillermo, thank you for answering the question on the chat there. I see that go through. Oh, we have a hand up. Hang about, we have a hand up. Who is that from? Ludo from China. Lu, can you have a question for Marcos? And it's gone quiet. I can't hear anything. Are you muted?
Oh, sorry.
Okay.
Can you hear me now?
Let's start again. We can hear you now. Thank you.
Thank you, Simon, and thank you, Marcos. Thank you for your introduction. And I wanted to know that does the Shipborne receiver support the SBAS function?
There is noise. I am not sure to understand you.
I didn't quite follow that, Lou. Could you say again, please?
Yeah, I wanted to know the Galileo receiver, does it support the EGNOS?
Does the Galileo receiver support EGNOS?
EGNOS, yes. Does it support EGNOS? Is it designed to be supported for SBAS?
So is your multi-source receiver, does that support EGNOS, Marcos? I think.
I understand the point. Okay, in terms of the project as it is today with the client use packet with the European Space Agency. No, okay, the program Space Agency. No, EGNOS is not included in the project. This is the point at this moment. Okay, it's true that we are thinking on it and looking for some interaction, but it is just coming from DMV. Okay, from our company, more interest, more internal interest, but not in the project at this moment.
Okay, thank you very much. Thank you. Any further questions? Thank you, Lee, for your question. Okay. Thank you for your time, Marcos. Very interesting and good to see that coming through. And every success we wish you with your project there.
Okay, thank you, Simon, and thank you, everyone. Okay,
bye. Okay, so now we move on to our last presentation for ENG15, and here we have to sit back and enjoy the antidote to the high technology from, in this case, from Jacques Manchard. Jacques graduated from the French National Public Works School some years ago and had a range of roles in marine radio navigation systems, and then was the IALA Council member for France from 1998 to 2011. And then he has been a senior advisor working with the IALA Worldwide Academy. And this presentation is on celebrating the Cordouan lens experimentation from the Cordouan Lighthouse, which is, I believe, a UNESCO lighthouse and a winner of the Heritage Lighthouse of the Year. So, Jacques Manchard, are you there?
Yes, hello, Simon. Can you hear me?
Yes, we can hear you. I cannot see you yet. Yeah, Jacques, nice to see you. Hello. Bonjour, bonjour. Over to you. Can you take the screen?
Thank you very much. So I will.
Are you in IALA there, in Saint-Germain?
No, I'm at home.
Okay.
I'm looking for the presentation. Oh, why? Oh, Yeah.
That's good. We can see the screen, but you are not in present. There we are. Good. Excellent. Okay. Over to you, Jacques.
Thank you, Simon, for the invitation to deliver a presentation today after such superb and interesting ones that have been delivered before. Ladies and gentlemen, good morning, afternoon and night, perhaps for everybody. I'm very happy and proud to be able to deliver that presentation, and I hope it will allow to collect efficient proposals for events we are looking to implement. So the proposal is about symbolic birthday. The invention of steps lenses by Augustin Fresnel completely revolutionized the lighting of lighthouses, and since then there have been only improvement in details, as it is said on Wikipedia. Fresnel first lenticular device was a rotating system, an application of Augustin Jean Fresnel's invention, and was tested in Cordouan in 1823. The device was stored in Bordeaux for the winter, then reassembled at the Cordouan lighthouse under the revision of Fresnel, partly by his own hands on July 25, 1823. It could be an event at the height of the invention. In July 1823, Fresnel installed the first step lens apparatus at the Cordouan lighthouse. It took him 3 years, almost day after day, to go on the ID stage to the final realization. The optics he established that day consisted of a central octagonal drum fitted with 8 stepped lens of 0.90 centimeters focal distance. At the bottom of the set, he installs crowns of metallic mirrors responsible for reflecting the extreme ray towards the sea. At the top, he places 8 small stepped lenses which take up the upper rays to reflect them on mirrors directed towards the horizon. The glass optic is held by a metal frame arranged around an axis of rotation. In the center of the optics, there is another important innovation, a lighthouse lamp equipped with 5 wicks. Finally, to prevent the heat from destroying the wells, he pumps out excess vegetable oil using a small clockwork mechanism invented by Bertrand Guillaume Carcel in 1800. As you all know, Augustin Fresnel invents the step lens. Augustin Fresnel, born May 10, 1788 in Broglie and died July 14, 1827 in Ville d'Avray, was a French engineer and physicist whose research in optics led to the definitive acceptance of the wave theory of light in replacement of the ballistic theory, which had imposed itself since Newton. Based on the concepts put forward by Christian Huygens at the end of the 17th century, and by carrying out his own experiments, he independently found the observations made a few years earlier by Thomas Young on interferences and gave them the physical and mathematical foundations who won the support of the physicists of his time. Augustin Fresnel died at the age of 39. Despite the shortness of his life, the excellence and importance of his work were immediately recognized by his contemporaries. He has been elected a member of the Paris Academy of Science in 1823, an associate member of the Royal Society in 1825, and received the Rumford Medal on his deathbed in 1827. Humphrey Lloyd, the professor of physics at Trinity College, Dublin, considered Fresnel's wave theory to be under bracket, the noblest invention that has ever graced the field of physical science, with the single exception of the Newton's system of the universe. It is said that Fresnel lenses are fitted to all lighthouses. To begin with, the event we are looking for, 3 lighthouses will be celebrating the event. These lighthouses will join together to celebrate the 200th anniversary of the lens. Experimentation at the Cordouan Lighthouse by Augustin Fresnel on July 25, 1823, and give a general public dimension to the event. Then they will be relayed to all parts of the world by playing on all registers: Fresnel, UNESCO, Cordouan, lighthouses, storm, lighthouse keepers, all the coasts in the world. Then a whole network of lighthouses gets in the tune. Let's have a look at the actions to be associated. The event would first take place in Cordouan, then will be relayed to the Grave Lighthouse and the La Coubre Lighthouse with guided tours, private tours, and meetings with the lighthouse keepers. We can also, bring the original Cordouan lens to the event near the Cordouan Lighthouse in a spectacular way in partnership with the island of Ushant. Involve all lighthouse networks around the event. Switch on the maximum number of lighthouses simultaneously in the world, for example, with the support of EALA. Organize a conference on Fresnel with simultaneous translation in English. Edit a souvenir object associating Augustin Fresnel, the Fresnel lens, and the Cordouan Lighthouse. Design a photo exhibition including Jean Guichard for foreigners and with Alain Rupi and Didier Grambert's very well-known photographs in France. Propose a large banquet on land and near Cordouan, which will bring everyone together. Involve the public by designing an interactive game and make Augustin Fresnel and his invention better known. We have to check with already a lot of project partners. The initiative is under the umbrella of the Association Phare de France, but we can also have a huge list of stakeholders that you can see on this slide. And also we will have resources and contribution with a lot of people already. Thank you to all the contributors that initiated the project. Here on the slide, you have pictures of the last meeting of the Phare de France Association that allow all the people in charge of the visit in lighthouses in France to exchange about their best practices. And if I may, I will go through some possibility of ideas already expressed. So we have to consider the impact at the local level, regional, national, and international. And so we have already seen in the previous list some of that topics. If I can go further in relation with EALA specific topics about ENG meeting or workshop or worldwide cooperation between lighthouse museum, the calendar could be as following: July 23, 2023, general communication and a day at the Pointe de Grave Lighthouse or in Cordouan, perhaps with 200 or 250 people. The first week of July, in relation with the EALA International Lighthouse Day, announcements of events in all participating lighthouses, various local events. September, October, other activities outside the summer season. Themes could be who is Fresnel, educational exhibition, photo exhibition, Fresnel, Blaze, light emitting diodes, why not R mode? Stakeholders to be in relation with, lighthouses managers, about alternative use of lighthouses, national authorities responsible for AtoNs, heritage authorities, regions, departments, towns, technicians, scientists, enthusiast people. We know there are a lot in USA, for example. We have to go through the organization about perhaps to implement a steering committee or other structures. We need to evaluate expenses about exhibition panels, land transport, that model that could be put in place, operational manager to along the process, and also an important point about funding. In France, the ministry is already thinking to put some money in the project, especially the DIRM SA, but it will not be sufficient, it's clear. So thank you very much. This is the end of my presentation, making a point on what has been looked at. I hope this subject will be seen as a good action to be implemented with the support of ENG. Thank you. I will be pleased to answer questions if there are some. And I know Solange Majoureau and Jean-Marie Calbet, who are part of the working group 4, will go further on that topic. Thank you.
Thank you, Jacques. Really interesting, and what a thing to celebrate 200 years from the Fresnel invention. And I think, you know, everybody has the Fresnel lenses in our estate, and very nice to hear this. And also, what a great focus for the Heritage and Culture Working Group 4. So it gives them a focus for next year and will align with the General Assembly. So thank you, Jacques. Any questions for Jacques on the Cordouan and the Fresnel lens? Not seeing any questions there. Okay. Well, that brings us to the end of the presentation session. I just really want to say thank you very much to the 8 presenters. I know it takes a lot of time to put these together, and we are grateful, because without your enthusiasm and your dedication, we would not have learned all that we have learned today. So I think it's been a very, very interesting time. Thank you for those who've stayed up where it is night time, and for those of you who got up early as well. So I bid you all good day, and I look forward to seeing you perhaps at other meetings, but if not, at the ENG closing ceremony on Thursday of next week. So goodbye to everybody, and thank you very much for your time, and a pleasure seeing you. Goodbye.
Bye.
Bye, everyone.
Goodbye. Thank you.
Bye.
Goodbye to everybody.
Goodbye.
Goodbye.
How are you there still?
Goodbye.